In this video, let's talk on linear inequalities in one variable. Example: solve 3x minus 4 is greater than 8. So, given 3x minus 4 is greater than 8. Now, the first step, just like your normal linear equation, you will collect the like terms. Collect the like terms. So this will be 3x is greater than 8 plus 4. Because if you have minus here and you take it to the other side, then it will becomes plus. So that means 3x is greater than 8 plus 4. Therefore, 3x is greater than 12. Now from here, we are going to divide both sides. Divide both sides by 3. So this becomes 3s divided by 3 is greater than 12 divided by 3. So 3 will cancel out. Therefore, s is greater than 4. Answer. Now, what is the meaning of s is greater than 4? What are the values of x? That is, s will be equal to, since s is greater than 4, s will take values from 5, considering whole numbers, 5, 6, 7, 8, 9, and so on. Now, on number line, if we represent this on number line, so this will be, let's say this is 0, 2, 4, 6, 8, 10, as in continue to plus infinity. Here will be minus 2, continue to minus infinity. Now, s is greater than 4. So you are drawing your line from 4. So let's say from 4 I have a straight line and I have this. Now all the numbers to the right here are greater than 4. And all the numbers to the left are less than 4. Because you have 2, you have 0, you have minus 2, they are all less than 4. You have 6, you have 8, they are all greater than 4. That means your arrow will go to the right because s is greater than 4. Now, this is the inequality. Now, if I have greater than or equal to, that means I have to shade this place. But if it is ordinary greater than, then leave it open. Don't shade that part. So this is greater than, don't shade. But greater than or equal to, shade. Now this is it on number line. You will see that from 4, there are some numbers here like 4.1, 4.2, 4.3, or 4.00, anything, 5, 6. So they are all greater than 4. That is number line. So now in closed interval form, the one we did in previous video, we can say this is also the same thing as in closed or open interval form, but this one is an open interval because it's greater than. So this is the same thing as s is a member of 4 comma infinity, because plus infinity is to the right. So this is how I can represent it in open interval form. Now let's see another example But before another example, we can prove this result. This is our answer. S is greater than 4. Now, values of S can be 5, 6, 7. That means any number that is not here cannot satisfy the inequalities. Now, look at the numbers very well. Which number is not here? We don't have, 9, 10, 11 it continue. But here, we don't have 4 because the number is starting from 5. Since there is no 4, there is no 3, there is no 2, so they cannot satisfy these inequalities. So we can confirm whether it will satisfy or not. Now put 4 here. This will be 3. This will be 3 brackets 4 minus 4 greater than 8. So 3 times 4, 12 minus 4 is greater than 8. 12 minus 4, that is 8, is greater than 8. Is that true? No. 8 can never be greater than 8, so it's wrong. That means 4 is wrong. Now, if you put another number like 3, any number that is not in the inequalities will not satisfy. If you put another number like 3, because 3 is not here, so this will be 3 brackets 3 minus 4 is greater than 8. 9 minus 4 is greater than 8. 5 is greater than 8. This is not true. So that means any number outside this cannot satisfy. Now let's put any number inside. Let me take 5 in short. So that means 3 bracket 5 minus 4 is greater than 8. 3 times 5, 15 minus 4 is greater than 8. 3 times 15 minus 4, 11 is greater than 8, is satisfied. So that means that is the meaning of all these values. So the correct answer will be S is greater than 4, and you can see it on number line and also in open interval form. So now let's see another example. So example 2. So let's say solve 6x minus 14 is greater than or equal to 13x. Now the first thing here is you collect the like terms. So collect the like terms. So now you are taking the unknown to this side. So and this is plus. Anytime plus is crossing, it will become minus. So this will become 6x minus 13x is greater than or equal to 14. This is minus 14 here. If it's going there, it will become plus. So collect the like terms. So 6x minus 13x, that is minus 7x, is greater than or equal to 14. Then we are going to divide both sides by minus 7. Take note, you are dividing by minus. Now anytime you are dividing by minus or you are multiplying by minus, this symbol must change. Now if it is greater than before, it will change to less than. If it is less than before, it will change to greater than. If it is greater than or equal to before, it will change to less than or equal to. If it is less than or equal to before, it will change to greater than or equal to. But in this case, we have greater than or equal to. So since I'm dividing both sides by minus 7, a negative number, then this sign must change. Take note. So this will be greater than, less than, or equal to 14 divided by minus 7. Now if it is 7s is greater than or equal to 14, nothing will change here. That is, s will still be greater than or equal to 14 divided by 7. Nothing will change. So take note. So now minus, we cancel out minus. So x will be less than or equal to minus 2. So that will be the answer. Now what is the meaning of s is less than or equal to minus 2? What are the numbers in this range? So now s will start from minus 2. That will be minus 2, minus 3, minus 4, minus 5, and so on. Now those are the numbers that will be in the range of these inequalities. Now if x is equal to minus 1, as you can see, minus 1 is not in this range. That means it cannot satisfy this inequality, because minus 1 is greater than minus 2. So put it, let's see. This will be 6 brackets minus 1 minus 14 is greater than or equals to 13 minus brackets minus 1. Minus 6 minus 14 is greater than or equal to minus 13. Minus 6 minus 14 minus 20 is greater than or equal to minus 13. Now if you say this is not true, so that means it's not satisfy the equation. But if you put any of the value here, it will satisfy. If you put any of this value, it will satisfy the equation. Now let's test minus 3. Let's say we have 6 brackets minus 3 minus 14 is greater than or equal to 13 brackets minus 3. This is minus 18 minus 14 is greater than or equal to minus 39. Minus 18 minus 14, so that will be minus 32, is greater than or equal to minus 39, which is true, because minus 32 is greater than minus 39. Note that minus 1 is greater than minus 1 million if it is negative number, but 1 million is greater than 1 if it is positive number. So that means the correct answer is s is less than or equal to 2. How can you represent this on number line? To represent this on a number line, so draw your number line. So let's say we have a number line. Now if here is 0, here is 1, 2, up to plus infinity to the right, here is minus 1, minus 2, minus 3, minus 4, up to minus infinity, like that. Now s is less than or equal to minus 2. That means I'll start from minus 2. Now because it is less than or equal to, I have to shade this. Remember, I said if it is less than or equal to, you shade. But if it is less than, I will not bother to shade this. But if it is less than or equal to, then I will shade. So now less than or equal to, or greater than or equal to, you have to shade. Now am I going this way or this way? So now look at it to the right. This is minus 2. You will notice now that minus 1 is greater than minus 2, 0 is greater than minus 2, 1, all these numbers are greater than minus 2, and all these numbers are less than minus 2. But the one we want is s is less than or equal to minus 2. So I'm going towards the left. So that means I'm drawing my line towards the left. Now this is the inequalities. But if I want to represent this on like using closed interval form, then this will be s is a member of minus infinity, because towards the left, to minus 2, then it will be closed here. So in my previous video on close or open interval, we use this for open interval, we use this for close interval. So now this is the answer to this question. Now let's see another example. So let's see another example. Now example 3. Solve the inequalities. Y plus 9 is greater than 5y minus 7. Now the first thing, collect the like terms. That will be y minus 5y, because this is plus, take it to the other side, is greater than minus 7 minus 9. So this will be minus 4y is greater than minus 16. Now because you have minus here, so you are dividing both sides by minus. That will be minus 4y over minus 4 is greater than minus 16 over minus 4. So minus will cancel out minus. So y is greater than minus will also cancel minus. But remember, if you are dividing by minus, the sign will change. So this will change to less than. So 16 divided by minus 4. So minus cancel out. So y is less than. Minus cancel out minus. So this will be 4. Now the answer is 4. So if y is less than 4, how can you represent this on a number line? And in short, what are the numbers that satisfy this? The numbers that satisfy this will be 3, 2, 1, 0, minus 1, minus 2, and so on. So all these numbers are less than 4. So that means on number line we can also have, if here is 0, so if here is 0, so here is 1. So this will go to plus infinity. Minus 1, minus 2, minus 3, minus 4, up to minus infinity. So now s is less than 4. So if you start from 4, then you are going this way, because all the numbers here are less than 4. So this is the same thing as s is a member of, so it's towards the left, so minus infinity up to 4, then is open interval. So you can watch my video on close and open interval so you understand this representation better. So that is the answer. Now you can confirm your answer. Anything that is not here cannot satisfy the equation. So that is it. Now let's see another example. Solve solve 2 bracket x minus 3 is less than 3 bracket x minus 1. So the first thing, so write solution. Then given 2 brackets s minus 3 is less than 3 bracket s minus 1. So now you need to open the brackets first. This will be 2 times x, 2x minus 6 is less than, that is 2 times s, 2 times 3 is less than 3 times s, 3 times minus 1. 3 times s, 3s minus 3. So now collect the like terms. So this will be 2x. You bring this one to this side. So 2x minus 3s is less than, then this one to the other side is less than minus 3 plus 6. Now 2x minus 3s is minus s is less than 3. So we have minus here. So if you have minus, this sign will change to clear the minus. So divide, that is, you can also say multiply both sides by minus. If you multiply both sides by minus or you divide both sides by minus, the sign will change. So let's say the number here is 1. So if you divide both sides by minus 1, you should have minus s over minus 1 to be greater than 3 over minus 1. So minus will cancel out. So s will be greater than 3. So now if s is greater than 3, what are the numbers that can satisfy this? That is, there will be, the numbers are 4, 5, 6, 7, and so on. Now on number line, let's say this is 0, 1, 2, 3, 4, 5 to plus infinity. So plus infinity. Now here will be minus 1 up to minus infinity. Now s is greater than 3. This is 3. Then you go this way because these numbers are greater than 3. In open interval notation, s is a member of 3 comma infinity. So this is it. So for plus or minus infinity, the bracket is always open. So that is it. Now in next video we are going to continue with examples. Thank you.